Okay, this, if I do a good job, this is not a very difficult concept. We are learning today about Bronsted. Now, I will just do this one time. This guy's Dutch, and so that O is supposed to be slashed, but I won't do that anymore. This is Bronsted Lowry acid-base theory. And you're also you're going to learn about Arrhenius acid-base theory, which is much easier. Arrhenius is basically acids start with H plus and bases end with OH minus. It's not as useful as Bronsted-Lowry. Bronsted-Lowry is the most important one because there's a whole class of compounds in chemistry that are bases that don't end in OH minus. And so what makes Bronsted-Lowry the best acid-base theory is that Arrhenius doesn't work for bases that don't have OH in them. But otherwise, Bronsted-Lowry and Arrhenius are equivalent with the exception of bases that don't have H in them. Okay, so the first thing I'm going to define, and these are key terms, so if you want to just write them down once, first of all, what is the definition of a Bronsted-Lowry acid? Um, I'm going to come back to these slides. So we're going to do a Bronsted-Lowry acid. I'm going to switch colors. It is a substance that is a proton. And remember, a proton is H plus. When you take hydrogen, which only has one electron, and you give it away, it has one proton, one electron, zero neutrons, and you give the only electron away, it becomes a bare nucleus with just one proton in it. And so acid is a substance that is a proton, oh, sorry, that, I missed a word, hold on, this is big. I was going to say that is a proton donor because that's how my other book says it. But your book says a substance that donates a proton to another substance. Okay, so acids are proton donors. And you'll hear me say this all the time. But when I donate money to a charity, my bank account goes down. So you'll hear me say this all the time. Donor down. Donor down. So when I do these, the acid is the donor, the H plus, because that's what a proton is going to go down. Okay, and then Bronsted-Lowry, notice I'm going to stop with the slashing the O. A Bronsted-Lowry base is just the opposite. Like when I donate money to a charity and the charity accepts it or receives it. And so a Bronsted-Lowry base, again, this is one of your 27 key terms, a substance that accepts a proton. Again, a proton is H plus from another substance. Sorry, it's hard for me to write real clearly on this pad. Okay, so there's two more key terms. I'm going to open up a new slide and then go back to blue. And then the other thing I want you to, and then this is a third key term of the day, a Bronsted-Lowry. Oh, by the way, they both did work on this independently. They were both kind of working at the same time, and they both published at relatively the same time. And so these two shared the Nobel Prize for this theory. So a Bronsted-Lowry acid-base reaction, again, one of your key terms, is the transfer of protons, which again, H plus uh, from one reactant which is the acid transfers its proton um, to another reactant. And then that's called the base. Okay. New slide. Two more terms. Yeah, these are weird words you're going to see a lot. We'll talk about this. Conjugate. Base. This will make more sense. I'll come back to these slides when we've done our 6 problems. Conjugate base. A base that forms. Now, this is really important. The conjugate base is being formed. That means it's not on the reactant side, it's on the product side. It's being formed when the acid loses a proton. And I'm going to keep just saying this. A proton is H plus. And then the last term I have to define. So you have 5 terms. The other day when we were doing titration, I think you had 6. So we're up to 11 of the 27. And a conjugate acid is an acid that forms when a base gains a proton. Okay, so there's your key terms. I'm going to do 6 examples with you. Really pay attention. This is totally weird. It's not hard, but you've never seen anything like it before. And so here is my first problem. We have HF and NH3 are the reactants, and the products are NH4 plus and F minus. And okay, the first thing I want to tell you about Bronsted-Lowry theory is there's always 2 things on the left-hand side of the arrow, or 2 reactants, and there's always 2 things on the right, and there's 2 things on the left and 2 things on the right, and then there's 2 pairs, and they're called conjugate pairs. Conjugate acid-base pair. Any conjugate acid-base pair are identical in all respects except for 1 more or 1 less hydrogen. So this is 1 pair. This is the only possible way you could pair these up, because this has F in it, this doesn't, this doesn't, this does. These are identical except for just this has a H, this doesn't. And then I'm going to switch to a different color. This is the other pair. This has N, this has N, this has 3H, this has 4H. So this is the other pair. Okay, so there's always like 4 doubles or 4 pairs. There's 2 things on the reactant side, and there's 2 things on the product side, and there's 1 conjugate acid-base pair, which something on the left pairs with something on the right. And they are identical in all respects except for 1 more or 1 less hydrogen. And so there's the 2 pair. Now look at the purple pair first. This is a pair, so just cover up these other 2. Don't think about them. This guy has 1H. This guy has 0H. Remember I said acids are donors, and donors, when you donate money, your bank account goes down. It went from 1H to 0H. The H's went down. That means this is an acid, which you probably already know because this is called hydrofluoric acid. And I started with the easy one. You know, acids start with hydrogen. because this is the acid, this is the conjugate base. Because this is the acids are on the reactant side. The acid and the base are on the reactant side. The conjugate acid and the conjugate base are on the other side. Now let's do this guy. Looking at the red pair, this has 3 hydrogen. This has 4 hydrogen. It starts at 3. It goes up to 4. The charity I give my money to, their bank account goes up. The donor's bank account goes down. The acceptor's bank account goes up. This is the base, and that means this is the conjugate acid. And there's just a couple things I want you to see. There's an A and a B on the left. There's a conjugate acid and a conjugate base on the right. And each pair, the purple pair has an A and a B, and the red pair has a B and an A. And if we go back to the definitions, okay, acid is the substance that donates the proton, and when you donate a proton, it goes down. Let's look at my first example. It had 1, it gave it away, so now it had 0. And then if you go back to this slide, a base is the thing that accepts the proton. And so what happens, this goes from 3 to 4, because what happens is this HF goes, hey, NH3, take my hydrogen. It gives it away. It turns over to F minus. And then when it takes it, NH3 goes up to NH4. Notice, no charge over here, +1, -1. But when it gives away this +1, this plus goes over here. This becomes positive. And when this plus goes away, this becomes negative. So another thing you got to notice is that the acid's charge goes down. So no charge, -1, it went down. The base's charge goes up. 0 + 1. All right, next one. 6 examples. The first one always takes the longest. Let's go back to black. We have, this is example 2. I have CH3, OH plus H2O goes to CH3O minus. By the way, in this chapter, there's a lot of -1s and +1s, and so they drop the ones a lot of times. And then H3O plus. By the way, this is called hydronium. Okay, so we have 2 things on the left, 2 things on the right. One of these is the acid, one of these is the base. Okay, let's do the red pair. This has to pair with this. Why? Because this has C in it, this has C in it. This doesn't. They have to be identical in all respects except for 1 more or 1 less hydrogen. And so then we'll have this, what do they do, red and purple, let's say. This is the second pair. No, and then 1 pair at a time. I see 4H here. I see 2H here, or protons. I see 3H here, and I see 3H here. And notice that you look at 1 pair at a time. Let's do the red pair. Started at 4, ended at 3, it went down. That means this is the acid, and this is the conjugate base. And then this was at 2, and then and now I'm doing the green pair. Was at 2, went up to 3. This is the base. This is the conjugate acid, and that's all you got to do. Acid base on the left, conjugate acid, conjugate base on the right. Each pair, red pair, acid, base. Purple pair, base, acid. Let's go back to this definition. A conjugate base is a base that forms when the acid loses its proton. Now, this is interesting. Remember how the conjugates are formed? So the conjugate base and the conjugate acid are always on this side. And this is now a base now, because if you did this reaction backwards, let's say you flipped it around and this was the reactant and this was the product, this would have 3 and it would go up to 4, and so that would be the base. So they're always opposite, A, B, C, B, C, A. If this is an A, its partner over here is a conjugate base, and if this is the base, the partner over there is the conjugate acid. All right, back to black. All right, 3, H3PO4 plus NH3 goes to H2PO4 minus plus NH4 plus. Okay, red pair. This has a P in it. This has a P in it. They have to pair. What do I do? Red, purple pair. This has an N in it. This has an N in it. So we got the red pair. We got the purple pair. Grabbing the green. This has 3 H's. This has 3 H's. This has 2 H's. This has 4 H's. Red pair first. Started at 3, ends at 2. When you donate money, your bank account goes down. 3 protons, 2 protons. This goes down. This is the acid. Should not surprise you. Things that start with hydrogen that aren't ions are acids. That means this is the conjugate base. And then this is 3 and this is 4. The charity that accepts my money, their bank account goes up. This is the base. This is the conjugate acid. A and B on the left, A and B on the right, A and B in the red pair, B and A in the purple pair. Not that hard. And it doesn't get any harder. 4 OH minus, which better be a base, but we'll check it out in a minute, plus H2CO3, which probably better be the acid. H2, sorry, no, that's not right. My notes are wrong. Hang on. This becomes HCO3 minus plus H2O. Okay, so I got 2 things on the left, 2 things on the right. You always have that in Bronsted Lowry theory. Let's do a purple pair. I'm going to do this one first. This has a C. The reason why I'm doing this first is this has O and H, this has H and O, this has H and O, this is, but this has to pair because this has C in it and this has C in it. And if that's one pair, then this has to be the other pair. And so what happens is this has 1 H. Its partner has 2 H's. It goes from 1 to 2, that goes up, that means that's the base and that's the conjugate acid. And then this has 2 H's and this has 1 H. And so this goes from 2 to 1, it goes down. Acids are donors, donors go down. This is the conjugate base. Look at your definitions. The conjugates are formed, they're over here. The acid, and then the definition of conjugate base is what is left when an acid, H2CO3, gives away a proton. Well, it had 2, now it has 1. It had no charge, now the charge has to go down by 1. And so this is the conjugate base, and then this is the base, and the conjugate acid, and the definition of the conjugate acid is the acid that forms after the base accepts the proton. This had 1 hydrogen, now it has 2. The charge was -1, now it's 0. It goes up by 1, so all these things kind of work together. This is 5. Getting a little bit more complicated, but it's really not that much more complicated. I'm going to be obnoxious in a minute. Plus CH3, COOH goes to CH3, COO minus plus CH3, NH3 plus. Sorry, this is a 3. Okay, you got to pair them. It's not that hard to pair. This has to pair with this. Has to. Because N, no N, no N, N. Okay, 3 plus 2 is 5. This guy has 5 H's. And then its partner, 3 plus 3 is 6. This guy has 6 H's. Goes from 5 to 6. It goes up. Donors go down. Bases go up. This is the conjugate acid. And then getting a different color, let's do purple. This guy has 3, 4 H's. And this guy has 3 H's. And 4 to 3, this is the acid. This is the conjugate base. And then my last example, usually it takes 6. which is C5, C, sorry, hold on, get the eraser. This is benzoic acid. It's one of my favorite acids from organic chemistry. So C6H5, forget it. I don't want to do that one. Let me do this one. HPO4 minus 2 plus OH minus goes to H2PO4 minus 1 plus H2O. Now, the thing that can get crazy about these is H and O and O and H and H and O and O and H, and all these have hydrogen and oxygen in them. But this has phosphorus and, sorry, not black. We got to do different color. This has phosphorus and this has phosphorus. They have to pair. This guy has one H and this guy has two H's, and the charge went up. And so this is the base, and that makes this the conjugate acid. And I know this starts with H and this starts with H, but these are actually ions, and so you can't really look at it. And so then the other two things that are left have to pair. This again, let's make this green. And so then this is the acid and this is the conjugate base, because this had one H and this has two H's. Okay, this can't be right. All right, this is a bad example. Do over. I'm not typing this. I am not. Oh, I know. Go back. What did I do wrong here? Sorry. So this. Oh, this is wrong. Sorry. Here's what I want to do over. My equation is wrong because I'm an idiot. Let me tell you why. HPO4 minus 2 plus OH minus. This is what would happen. This would go to PO4 minus 3, and this would go to H2O. So then when I grab my colors, this has to pair with this, and this has to pair with this, because these are the only two that have phosphorus. And so this, you can see that this guy's giving the hydrogen here. So this has one hydrogen, and this has 0 hydrogen. Goes from 1 to 0, it goes down. This is the acid, this is the conjugate base. And then this goes from 1 hydrogen up to 2 hydrogens. It goes up, so this is the base, this is the conjugate acid. And that is enough. You have a whole bunch of these to do on your worksheet.